Time to get to the fun stuff, everyone. We are currently sort of poised to begin breaking these things off and playing with the information in such a way that it's going to benefit us. So if I have, coming out of these exports here, so outputs, I have 4 groups of different types of surfaces. Coming out of this, I have 4 groups of numbers. So what I'm going to wind up doing is, if you look back here, I have oh, you know what's funny? Sorry, I just thought of another way to simplify it too. Sorry. Anyway, so what I have back here is basically the surfaces get fed into, they get fed into the modifier, I guess we'll call it. You know, the thing that we actually made. All of this information that we put back here is just to segment information that we need. And in fact, part of it I didn't even really need. I think I only need this one. I don't think I need the number one. Now that I think of it. Anyway, so what we're going to do, and let me just plug this one in instead. What we're going to do is basically replace this all-inclusive input, right? So this right now houses every single surface that we plugged in. If I hover over, there are 16 surfaces going in. What I need to change is I want to segment a package of information to give it. And then I want to create an alternative grouping of modifications that I can assign to the next package of information. So how might I do that? Well, let's take a look at one of the options you're well aware of right now. Under list, if I go to list item, let's take a look at what that's going to give me. But to start off, I'm just going to drop in a slider of 0 is less than 3 because I have 4 items. Plug that in. And then I'm going to feed in the list. Drop another panel in to see what we got. What do I wind up with?
First surface of every set.
So what we need to do is find out which of the grouping options we have in order to, or we need in order to actually get a particular part of that list. So, and this one, I'm thinking back here. You know, that I don't know. I don't think so. Because I want to... I might have forgotten. Sift pattern, longest across combine data, weave, pick and choose, pick and choose, pick and choose. I think I forgot. That's weird. Sets, subset, test 2 sets for inclusion. Set difference, the difference of 2 sets. Oh, darn. Hold on a sec, I gotta look something up. Okay, so new concept here. I had to refresh myself because I don't really work with these kinds of trees too much. But the information that you're getting, and this is another way of looking at things, right? I keep giving you different ways, different frameworks of reference. But another framework of reference that you can operate on is to think of these data structures as trees. So this is a tree graph, and it just shows the structure of the information as it's being passed through the system, right? And it traces it back to its origin. So if you hover over this, right, you've got 4 values that come out to the next level where it's been modified. And then it gets broken apart, and the function right here where I actually partition the list into 4 parts, that's what you're seeing between here and here. And then this red dot layer is essentially the partition, the output of the partition, and then you've got your result right here. So those are your 4 separate groups. So, and we'll talk a little bit more about trees. We don't typically, I probably should explain it to you more at some point. But when you're working with a list of sets like this, and I think I might be using dynamo terms here, but a list of sets, you have to explode that tree in order to get the individual groups. So I'm just going to feed it to you here because it's tough, it's difficult to understand, but basically you go under set tree, and it's this one that's called explode tree. And the developers had a sense of humor because they called it bang. But it's going to separate those into individual bits and pieces. But notice that when I put it in, it gives me an error. And so here's kind of the most appropriate time to show you another sort of hidden feature of Grasshopper, is that if you read the description, it says the tree contains more branches than this component has output parameters. So you can modify a lot of these definition nodes. And the way you do it is you zoom in to a point where these pop up. So this is a way for you to delete an output or input or add. So if I add 2 more, then I get 4 output values, which means that I can now actually select each individual branch. Does that make sense?
And what types of nodes does that work for? Certain types? Like
Yeah, not all types. Like if you zoom in on partition, it can't, because it's a function that serves one purpose and one purpose only. I'm trying to think if we have any that we can add. Probably some of the math ones would. I don't know if you can do it with addition. Yeah, so addition, you can add multiple numbers in, that kind of stuff. But you can't do it with divide because that's a compound mathematical operator. Okay, so moving on. This is under set tree. And now we have the ability, and I'm going to yank this one way out here. Now we have the ability to override some of the surfaces that we're working with up here. So I'm going to take my group 0, which is the smallest, or which are the smallest surfaces that I have on my building, and I'm going to override it. So now here you can see that the 4 smallest surfaces on my building are now currently mapped. And I can reduce the number of subdivisions. So instead of 5, I'm going to reduce this to 2. And then here's the important part. For something like this, because it's a fully, closed idea, right? I can't just start feeding in multiples into the same operators. In some cases I can, but since I only have a couple of different types, I don't want to deal with trying to figure out how. So I'm just going to select the whole group and paste it, copy and paste it, pull it down, and then it's as simple as, oh, I need this too actually. Oh, darn. Sorry. I want to select that with it. Like this. copy, paste. The reason I wanted to select it with it is because then this will actually stay mapped to everything. And it's as simple as replacing that connection with connection number 2. So now my 4 medium, low medium, I guess, are going to have, I'll bump it up to 3 subdivisions. And I'll control paste again and replace it with number 3. And I'll bump that one up to 5 subdivisions. And paste again. And replace that one with number 4. And this one, I'll try 7. Okay, so we have a lot of geometry in the background here that probably doesn't need to be on, so I'm going to select everything back there, turn it off. And now you can see we have a building that's actually going to read like it's a little bit more well thought out, a little bit more authentic. Okay, so what questions do you have about that?
What was the command that's feeding into those 4 branches?
Bang. It's under set tree, explode tree.
And that's feeding into, or feeding from...
It replaces the surface reference into each of your mapping blocks.
What's incoming or inputting into explode tree?
Your partitioned list. You want to see it again as a panel so you can be sure? So this partition list is feeding into that, which breaks apart each group of 4, and then you feed it back into each of these modifiers. Okay, so it looks like I thought I was going to have to remap based on the numbers, so I don't need that. These panels were purely analytical, so I'll get rid of those. This was an exploration from earlier where we were just analyzing, purely analytical. We don't need that. So now you can kind of see that it's starting to actually look pretty simple, right? This is actually kind of a simple thing. It is. It actually is. So let me move that up there. Put this here. So this is everything from yesterday. We just copied 4 times. And really, this is what we built today. Okay, so I'm going to recap everything from today so far. And basically, right, we did an intersection to analyze the surfaces. I was thinking through something. We remapped it based on the length, so we did need to find the length, but we didn't need to reorder the length and use it necessarily. I remember why. I'll explain it in a second. But we used the length, and then we remapped the ordering of the surfaces based on the restructuring of the lengths in order, right? So we did that by using the length value. And then we just basically partitioned that list into smaller groups, which we broke down into selectable groups, and then we fed it back into the surfaces. So we explained a lot, but really it's not all that much actual work that went into it. And you have a fully versatile system. Okay, so what I did want to explain is, it took me kind of a roundabout thought process to get there. But when you think about this, right, so this is kind of the crucial point here, how we remapped the numbers. And I kept kind of going, I battled with myself about, do I actually need to remap the numbers versus the surfaces? Well, I did, and the reason is, well, maybe I should just ask you, why do you think it was important that I remapped the order of my surfaces based on the length instead of the area? Why was it important that I did not, or that I used this, right, the length of each of the surfaces to remap and order the surfaces from smallest to largest, rather than the area? Because the area, I wouldn't need this if I just, analyzed area and then plugged area in there.
Well, because area could be, you wanted to find surfaces that were specific lengths, and if you just put in area, it could be, it can be taller. Like, I'm not sure if I'm explaining it right, but.
Yeah, well, you're exactly right.
I guess we're trying to narrow down what you're looking for.
Exactly. So we have in our massing, we have buildings that are at varying heights. So I mentioned it briefly earlier today, that the reason we want the length instead is because a tall building, if we measure the area, is going to have a larger number than a very narrow, or a narrow tall building is going to have a larger area than a regularly spaced small building. So it'll mess up your ordering. So what questions do you have about that? Oops, lights are out. Okay, so what we're going to move on to next, actually, is, well, I'm going to show you real quick kind of how that, I think we're going to run into a problem when it starts to do multiple buildings at once. And we'll troubleshoot, well, maybe I'll give you guys a break on troubleshooting. And we'll, what we're going to do is, how do you actually isolate certain ones and modify within the pattern to create something that's more interesting? Just a thought, okay?
Instead of just like rectangular subtractions.
Right, yeah, instead of just rectangular subtractions.